We can make it right, yeah. I need my background to help me sing.
Well, good morning, ladies and gentlemen. How are we up and at it on Friday the 13th? There you go, of May. Welcome, welcome, welcome. I know for many of you it's your first time back on the conference scene for a while, maybe even a year or so. So for many of you also, now it's just that first time in a while you've felt that feeling of the morning after a gala dinner of what the hell was I thinking last night. It's great to see you all here. Actually, in some ways pleasantly surprised at the size of the crowd morning after a gala dinner, but not at all surprised given the keynote speaker we've got to kick us off today. We at AusCERT are so excited to have her here. This is in fact her first visit to Australia. She's cuddled a koala, she's done it all, she's ticked everything off the list, and she's here in her capacity as the Director of Incident Response for North America at the industrial cybersecurity company Dragos, Inc., leading the response to and proactively hunting for threats in customers' ICS environments. I've always hoped that Dragos was actually pronounced Dragos. It is Dragos. Oh, my apologies. Oh, fan, so as in after Ivan Drago, the Russian heavyweight champ from Rocky IV. Oh, I was hoping the dude who killed Apollo Creed before succumbing to Sylvester Stallone in a brutal slugfest. Anyway, she's not a boxer, but when not working, Lesley enjoys being a youth martial arts instructor. So it's a little bit more Cobra Kai than Rocky IV, but it's a start. You may also know her via her iconic Twitter feed, Hacks for Pancakes. She manages a team of incident response and digital forensic professionals across North America, and she's here to share her stories from the field on the topic of uncovering the invisible world of ICS cybersecurity. How about a massive round of applause for Lesley Carhart?
Thank you, sir. Wow, look at all those hungover faces out there. Kudos to the 5 of you I saw at the gym at 6:30 this morning, near tears, so good job, everybody. It's nice to see you all. Thank you for having me here at AusCERT, and thank you for having me in your wonderful continent and country. This is also very exciting for me. As mentioned, I did, in fact, can I have my slides? I did, in fact, get to hold a koala, and it was very exciting. So I'm Lesley. I drink and I know things, and I'm going to try to convey some of that knowledge about useless facts to you all, hopefully useful facts for a few of you, about what I do. And I have a really weird job. As mentioned, I do specifically incident response for industrial control systems. And this is a weird niche because I'm one of the few people in the world who, when there is, say, a cybersecurity compromise of a power plant or a train, my team gets called in to do response to that. So these weird, non-standard computer systems. But they're really not that uncommon, okay? You probably have industrial control systems in your environments. And I have like 40 minutes here to tell you everything I possibly can about what you should do about that, because it's really, really important. We're going to talk about what these systems are, where they live, what they look like, and how to understand them. We're going to learn some basic terminology so you can talk to the people who work on those systems. Next, we're going to talk about the threats they face and why I'm even here, why I even do what I do other than take glamorous trips to other continents, which happens to me all the time, definitely. Not really. Anyway, and then finally, we're going to end with building your own industrial cybersecurity program from the ground up. So if you've got nothing there or you're just starting, I'm going to give you all the tips in a short period of time that I can possibly give you to start building that program. It's really, really, really important. So let's get rolling, okay? So ICS fundamentals, industrial control systems. I have a lot of words in some of these slides, so you can take out your phone and you can take a little picture and take it home with you, have some homework, have a nice picture to post on Twitter, whatever. This is for your reference, but let's talk about some terms I'm going to use in this talk. So the first one is operational technology, or OT. Now this is a fake made-up word. Sorry to everybody here who uses that word frequently in their marketing material. It is a term that we've made up as IT people to describe stuff that is the other, that wonderful anthropological concept of the other. So when we're talking about OT, it's us using it as a differentiator to talk about this industrial stuff, this non-typical computer stuff that's doing process things in our environments. And you don't really see like industrial engineers and operators using those terms. So who are these industrial engineers and operators? So operators are the people who kind of make the industrial process run. So they watch little screens and they see how the process is running, they make sure it's safe, they adjust levels, things like that. They're sitting in the control center. And then we have the more technical engineers, whether they're mechanical engineers, electrical engineers, chemical engineers, who are doing the detailed management and analysis of the process. So you have your operators and your engineers who are working on these industrial systems. But finally, let's talk about what an ICS actually is, an industrial control system. A lot of you are imagining a PLC right now, like a little ruggedized computer, but there have been industrial control systems for ages and ages and ages and ages. They can be gears and pulleys. They can be mechanical. They are simply a thing that takes input and makes decisions somehow about a kinetic process. So it could be, again, gears and pulleys, something simple like that. Industrial control systems have existed since like early water clocks. So you can do this mechanically. You can do it with analog control. So for a long time, industrial control systems were simple electronic systems that made decisions. And now they're more computerized and digital. But there's still plenty of mechanical industrial control systems out there. There's still plenty of analog industrial control systems out there. So that's why I'm going to tell you right now, the terms ICS and SCADA are not interchangeable. We hear people use them interchangeably all the time. I'll tell you in a little bit what a SCADA system is. But an industrial control system doesn't necessarily contain SCADA. It can, again, be gears, making something happen mechanically. But what's this process that I'm talking about? Or process, if I say it properly. The conflict of world verbiage there. So a process is a series of discrete things that make something kinetic happen. So it could be all kinds of different stuff, right? It could be something as complex as electrical power generation, so you're generating electricity, a kinetic thing, or it could be something as simple as a door opening and closing. So it's a decision-making process, whether that's gears and pulleys or a computer system, making a physical kinetic thing happening. And processes can have lots of sub-processes. I mean, think about like canning tuna. I always use this example. I use it around the world. I've now used it on like 3 continents. So canning tuna, you have your conveyor belt that has, your cans. You have to fill the cans. You have to put the labels on the cans. Each one of those things is a sub-process that makes one big process that is sticking tuna in cans that have a label on them and they're sealed and things. It's very exciting. All right. Processes are made up of process loops, okay? And a process loop has 3 parts, okay, everybody? It has a sensor, a controller, and an actuator. And let's talk about what each one of those things is. So first of all, you have to have an actuator. That's the thing that makes the physical thing happen. So that could be making a motor run. It could be changing a temperature, opening a valve, making a conveyor belt move, et cetera, et cetera, et cetera. So something physical in the world. Something has to make decisions about what that's going to do. So there's some kind of control device. And again, that could be digital, which we're mostly going to talk about in the cyber world, but it could be a mechanical thing as well that makes decisions about when that actuator does something. But it has to have some input, right? There has to be something that helps it know when to do things. So you also have to have some kind of sensor in your process control loops. So let's look at a pretty simple, familiar example here that I really, really like. We actually don't have one of these in the hotel. I'm very disappointed. I put this in my slides, and this ritzy hotel doesn't have an automatic revolving door. But raise your hand if you have seen an automatic revolving door, just checking. Okay, everybody's seen an automatic revolving door. Has anybody walked into one? A few times. I've walked into an automatic revolving door. So this has a process control loop, and it has these 3 things. Think about it for a moment, okay? So what happens when you walk into the door? It starts turning, right? So that's the actuator getting to work. But it had to make a decision about when to start turning. So there's also a sensor, right? There's a sensor to tell if you're in the door. And then a controller takes the input from that sensor and says, there's somebody in the door, and I need to start turning around, okay? So that's the basics of the control loop, but there's more things, right? Because if you get too close to the door and you impede it, it'll stop, right? There's a safety control. So the actuator is actually providing feedback to the controller as well, and it says, I can't turn, stop, it's not safe. So there's like bidirectional feedback going on in that control loop as well. So there's safety built into these doors as well, and I always use this example to understand how these process loops can potentially fail. So what can go wrong? There are only 4 failure states for any process loop. Okay, so the first one is the actuator fails to start when it's supposed to. So think about your door. What happens then? You walk into the door and it doesn't turn, and you're like, I would like to go now. No. So not too bad in that case, in that example. Fails to stop when it's supposed to. So you walk into the door and it keeps trying to turn in your face. That's rather unpleasant, right? The third one is it starts too early or too late. So you wait for a little while, or it keeps turning into your back while you're getting out of the door. Very unpleasant, but probably not life-threatening. And finally, it goes on for the wrong period of time, which in that case has similar results. Every process loop on Earth can have those 4 failure states, and they can get much more severe than a revolving door, although, mea culpa, there are apparently a great deal of injuries caused by revolving doors over time across the world, so they actually can be dangerous for those reasons, in those failure states. But real industrial processes, they are much more complex than a single process loop. Usually they have a multitude of different things going on. I talked about canning tuna earlier. You have the conveyor belt going, you have the stuff filling the tuna, and everything has to be synchronized together, because like if it's not, then you have tuna on your conveyor belt, and it's disgusting, and somebody has to clean it up. So these process loops have to work together. They have to have feedback between one another. So you have to have some big computer that's making decisions about all the little computers and when they do things. So they're coordinating them all. And for a long time, in the digital world, that was distributed control systems, or DCSs. Now we're seeing those, which are smaller scale, and more elaborate SCADA systems to integrate a bunch of parts of a process together, sub-processes into a bigger process. And that's where we pull in SCADA systems. We're talking about this picture up here, which is controlling a bunch of process loops, getting feedback from them, and coordinating their efforts, perhaps over a very large geographic area. So there's your SCADA. Process control is super complex. There's a lot of things going on in these processes. There's a bunch of sub-processes with different devices, different sensors, different actuators, and they have to work together, right? So that means a bunch of protocols and things. So I'm going to introduce you here to the Purdue Model. This is a model that is educational, it's academic, it's not always representative of everything that's really going on in industrial control. But you can see we have a layer cake here, okay? So at the very, very bottom, we have our very simple analog digital devices. So our things like our sensors and our actuators. And as we move upward, we get into more familiar devices. So at level 1, you start to see your PLCs, so your ruggedized computers, your control devices, simple computers that have, simple ladder logic programmed into them. And at your second level, you start to see things like maybe some familiar Windows computers, like HMIs. So you might have a Windows XP embedded system there that is your control interface. And that talks to the lower levels, but it might also talk to the upper levels too, because as you go up further, you start getting to like workstations where the systems are programmed, so actual Windows workstations or Linux workstations. Then you hopefully have some kind of DMZ, which separates you from the rest of your corporate environment, your normal, familiar enterprise environment. So that's the Purdue model. So the low-level devices are less familiar. The higher-level devices, before you reach the DMZ, are more familiar, so potentially Linux, Windows, etc. Now, why is this important to all of you? Well, I'm here to tell you that you do probably have industrial control systems in your environment. They're all over the place. So not just in manufacturing, not just in transportation. We do a lot of ICS research on trains and aircraft, but also things like your building automation and control. We respond to a lot of incidents in data centers around the world where there's been an intrusion on, say, the fire suppression system or the heating and cooling. What happens if you're in a very, very hot place and all your air conditioners suddenly get infected and fail? that has a big impact to how you do business, even if you're only working in the computer world typically, right? So you really need to think about these control devices. And is anybody else staying in the hotel with the little button on the wall that has the controller for your blinds and everything? So mine crashed while I was here. The electrician had to come up to my room and reset the controller that makes the light switches work in the room. It took 20 minutes to reset. So we are surrounded by industrial control and Internet of Things devices that control these process loops. We're surrounded by them all the time, and they do important things that we often don't notice until they fail. Now, there's a concept that I need to introduce you to called Itot Convergence. And Itot Convergence means simply, it's cheaper to use commercial off-the-shelf thing to build these process loops than go build your own, roll your own. It's also safer to typically use something commercial instead of rolling your own protocol or something. So we are, in the industrial space, seeing more and more familiar network infrastructure devices like Cisco and Juniper, and Windows computers doing a lot of these control tasks, especially at the mid-levels of the Purdue Model, but also at the lower levels, because they're cheaper and easier to replace and implement and build. So of course people are using more of them. They aren't building their own network protocols like they used to. Things are running over Cat 5, Cat 6 between the industrial devices. They're running through typical switches and routers like we see in our enterprise environments. And that means they're vulnerable to all of those things that those devices are typically vulnerable to in the cybersecurity world. So this has changed a lot of the vulnerability landscape of industrial networks. So I want you to think for a moment. I've told you probably have an industrial control device in your environment. Think about this. This is why you might be missing them if you aren't aware of them right now. They're oftentimes on different subnets or VLANs. So like your building automation and control, your backup power, your heating and cooling systems, your elevator controllers, or even the things that do your shipping and logistics, like your RFID tracking systems, et cetera, for shipping. They perform key tasks that are not considered because you're not necessarily thinking about your processes. You think about cybersecurity in a vacuum, which is okay in enterprise, but now we need to think about these processes, right? These control loops, these things that are happening to accomplish our mission. And we oftentimes get the message that these systems are too sensitive to touch or look at as cybersecurity people, so we're told to ignore them. We're told to write them off or check them off in our risk assessments. Because there's something that's foreign and unusual, they're low-level devices, and we're scared to break them for good reason. We don't want to bring down our process, and we'll talk about that. And there's oftentimes an unhealthy culture, relationship between the operators and engineers and IT and cybersecurity because there's been misunderstandings and miscommunications for so very, very, very long. All right, so let's talk about why we care. Okay, so incident response. I do incident response in these systems, right? I respond to 3 types of cybersecurity incidents in ICS typically, okay? The first one is insider threats. Now, one of the first industrial cybersecurity accidents actually happened very close to here. It was a sewage plant. This happened back around 2000. A fellow working at the plant found out that he didn't get hired on. He was a contractor and he wanted a job there. And he got so mad that he went and he dumped a bunch of sewage into a nearby water body. And it was a horrible mess. But this was a great example, and this was long before Stuxnet and anything like that. This is a great example of the people who work on these systems. 95% of them are great people, 99% of them are not going to do anything bad. But there's always that 1 or 2 people who know how to break the system, and they have a bad day, or they get pissed off at their boss, and they decide to break something. So that actually does happen. We do respond to incidents that are insider threats in these environments. But they're not always intentional. Sometimes the operator who's working at 2 in the morning just wants to watch Netflix. Like, yeah, okay. And they plug something in, and they infect the system. Commodity. Ransomware can have huge impacts on those mid-levels of the Purdue Model. If you suddenly can't see your control screens because they've got a ransomware screen on them and they're running Windows XP, you got to shut down your process because you can no longer operate it safely. You don't know if it's on fire. You have to shut things down. So ransomware can be very impactful, same with crypto miners, et cetera, things that bring down these low-resource systems, older systems. And finally, there's targeted. And at Dragos, we track a bunch of different adversaries that are trying their hand at poking at industrial systems. And a lot of what they're doing is foothold building and reconnaissance, so that's changing over time. You know, they're staging for future attacks. They don't want to waste all these resources in making something explode right now. They want to build a foothold, and they want to understand the system because the processes are complex and they're hard to break in a specific way. So they're taking their time now and learning how they work very quietly and slowly in these environments so that when they need to, in a geopolitical context, they can make something explode. All right, so I've told you all this. I've told you got ICS, oh my God, and I've told you that you probably need to do something about it, and that there are people out there who are getting better and better and better at breaking it for a multitude of reasons, whether it's the ransomware actors just wanting money, or the advanced adversaries learning about and staging for future attacks. By the way, you are not too small for that to be you. They use a lot of small operators as test beds for their attacks on bigger stuff. So that's not great, right? So I'm going to give you a little crash course in building an industrial cybersecurity program for your organization. And this can be little. It can be just for your building automation and your HVAC systems if you need to, if they could impact your operations. This is an important thing to do. So I've got my top 7 misconceptions. I want to start with this. These are my top 7 misconceptions I hear from everybody about industrial control systems. So let's get this out of the way. The first one is that it's an edge case, that it only applies to, say, manufacturers or power companies. No, it's all over the place. We already went through that. It has to be out of scope for scans, pen tests, and assessments. No, we just have to do them differently because these systems are older, legacy sensitive, doing critical health and safety, life safety things. It's arcane. No, we looked at the Purdue Model. The low-level devices might be less familiar, but the mid-level systems, we're talking Windows XP embedded, Linux, things that you are familiar with. There's still Cisco devices there now. Itot Convergence is seen to that in a lot of cases. You can learn this stuff. It's protected by air gapping, data diodes, and segmentation. Air gapping is a lie. I've seen 1 to 2 networks in my fully ICS career that are actually air-gapped in a year. A lot of organizations will say they're air-gapped, and I'll actually go in there and take a peek, and there's like modems connected to them, and there's a DMZ, and there's pass-through in the DMZ. People have odd ideas about what air-gapping actually means, and even the environments where they are air-gapped, they have to do updates, right? They have to do software programming. So somebody comes in and plugs in a transient laptop, and they bridge to the network, or they bring in a USB drive. Something has to bridge, even if it's SneakerNet, even if it has to be a human being walking in with a USB drive. So air gapping is not common, and it's not necessarily a reliable defense. I don't see a lot of data diodes. They're a nice idea, but they're expensive. So really, we have to think about other more traditional defense in depth in terms of cybersecurity. Purposefully neglected. It is not purposefully neglected. These systems are legacy for a reason because the life cycles are different in industrial control. When you go out and you buy the equipment for a power plant, you are buying that whole setup, that whole system, and support contracts for 20 years maybe. And you're buying a really big, expensive package. And you can't just tamper with that. It all works together, all those bits, all those process loops, all those parts of the Purdue Model. They all work together, all those different protocols that are used at various levels of the Purdue Model. They all have to function together, and if you start replacing operating systems or adding EDR or something, you're going to make something fail. You have to work with the vendor and the engineers on that, and it can take a very long time. You might only have a maintenance window in these environments once or twice a year. Is it easy to secure with NextGen? No. We can't install EDR on our XP embedded HMIs. I'm sorry. We've got to go back in our time machine to 2002, and we've got to do good security in depth, and we've got to adapt to the fact that we're dealing with a lot of legacy systems and a lot of very sensitive systems that we can't tack things onto. And that it's vulnerable simply because individual devices are insecure. These protocols and devices are made to be simple so that when you hit the giant red button on the wall to stop somebody from being chewed up by a machine, the connection happens really fast and the machine shuts down. If you add encryption to that and overhead to that protocol, that could be another precious couple seconds, perhaps, or something could fail. You need these protocols to work reliably. Reliability is number one in these environments so that these systems can function safely. So real talk. Here are some real facts about industrial control systems for you. So the first one is, I already mentioned, industrial cyber attacks are increasing. I have more incidents every year. It's really happening, and adversaries are getting better at attacking them. As I mentioned, these industrial control systems, they often use legacy stuff on purpose, longer lifespans. That's how they work. They have to function. They have to function reliably without a bunch of downtime. Familiar IT stuff, as we mentioned, IT-OT convergence is happening. You will see more IT stuff in these environments as time goes on. It's happening more and more, and that means IT vulnerabilities. Air gapping is a lie. I'm sorry. It sounds really great. If you hear that word, double check everything. Don't take that term at face value anywhere. Protocols rarely have authentication or encryption. As I mentioned, when you hit that giant red emergency button on the wall, the system needs to stop. These protocols are simple for a reason. They are unencrypted for a reason, because the number one thing here in the CIA triad is that you need to have reliable protocol going to the devices so that they do what they're supposed to do at the right time. ICS can be sensitive to scanning and exploitation, absolutely. These are simple devices with simple protocol stacks. But there are still ways to do cybersecurity, whether it's testing the systems during their maintenance windows, or using sometimes we have a digital twin system where somebody has a little lab where they test the systems. Maybe we can do some testing in there. There are ways to work around this, but we have to be adaptable and communicative. And ICS is comprehensible. This is something you can learn. You just have to focus on an area, and you have to understand the process that you're dealing with. So the very beginning of this is identify what processes you have to secure. What process environments are in your purview as a cybersecurity personnel, even if it's just something like building automation. And you need to have healthy conversations with your engineers and your operators. These people might not trust you at all. You're the people who don't let them go to websites. You're the people who say they can't watch Netflix when they're bored at 2 a.m. So I do suggest pastries. That's a really good tactic. Bring in a box of something and sit down and say, teach me about your process. They are much more educated and informed about their process than you will ever be. So let them educate you. Learn about the processes you have to secure. Learn about how they're maintained, what their concerns are. They already do business continuity planning. They know what they're concerned about. They know what could go horribly wrong. You should be asking these people these questions and listening and being humble. So we have the cybersecurity maturity model here. So the basics are the thing you have to get out of the way in any cybersecurity. You need to start at the very beginning. You need to start with understanding your environment and the architecture and what you actually have to secure. So what are we even securing, and how are we going to find it in our network? So let's talk about architectural understanding of these environments. This is where you should start after you understand the processes that exist. Okay, what's the process, and who's involved in it? What are they concerned about? What is their worst day ever? Do they have business continuity planning? What vendors are in place? And what types of cybersecurity tools are already deployed? There might be some simple antivirus. There might be some logging that could be useful to you. So again, you've got to listen and have those conversations with your engineers, with the OT staff. They know these things. And if you don't push them and try to push modern cybersecurity onto them in an inflexible way, they will be willing to educate you on what's there. Asset inventories. This is tough in IT. It's really tough in OT. A lot of you probably have some idea where your systems are and what they're named in your IT environments, but these different VLANs and subnets and segments that your industrial equipment live on are probably unknown or barely known to you. And this means that you have to start from scratch with this whole asset inventory process. So you're going to need to find ways that work with your sensitive industrial environments to get asset inventories. There are tools out there. Typically, they do this passively. So they collect network traffic off a span port or a tap, and they build an asset inventory. You can't install agents on everything. You can't go out there and do active scanning on everything. The best tactic is to do things passively and carefully, and again, work with your operators and engineers. You need network maps. You need up-to-date and routinely updated network maps. Again, these are not the same as your IT network maps. They're going to involve every level of the Purdue Model. And you need to understand, from a process perspective, how the network is laid out, and what's sensitive. So that means, again, you've got to work with those operators and engineers to start understanding the layout of your environment. Now we need to understand what actually matters from a cybersecurity perspective. So we need to do some crown jewel analysis. And really, this is something we should be doing in IT, but we're really bad at it. OT people are really good at thinking about their worst day ever. They do that from a safety perspective all the time. That's part of business continuity planning. Thinking about, hey, from a very high level, what does my worst day look like? Is it somebody dying? Is it the facility catching on fire? Is it my multi-million-dollar piece of equipment grinding to a halt and destroying itself? They already have an idea of what those consequences are, and what you're going to need to do is start at the top with the mission and those consequences of concern, and understand, mapping downward, what parts of the process, what devices, what sub-processes could cause these consequences to happen. This is actually kind of a tricky thing and a long-term thing that you need to do. And we should do this in IT too, but it's very, very critical, life and safety, to do it in OT. So as I mentioned, we start at the top. What is the worst day ever? And then what parts of the process could cause that worst day ever? Are there mitigations in place that could prevent those terrible things from happening? Are there human safety controls, physical safety controls that prevent things from exploding or catching on fire? How reliable are those? What could cause those to fail? And we map downwards and downwards and downwards until we have a really good list of very specific things, like software things or hardware things, that could cause those terrible consequences to happen. Those are the things we actually care about. Do we care if configures on every Windows computer system? I don't know. We might not care if every computer in our industrial environment has configure on it, because it does not cause a consequence of concern. This is a different way of thinking for cybersecurity people. We care about exploits, we care about malware, we care about there being infections on stuff. You have one day of downtime in these networks a year. You're probably not going to shut down your entire process at millions and millions of dollars just to go remove configure from some engineering workstations. They're working okay. You can make a risk assessment and say it's probably not going to get worse. It's a headless worm now. And keep things running. You need to make those types of risk decisions about the consequences that you actually care about in your industrial environment. This will help you prioritize what you do in incident response. It'll help you run threat hunts. So this crown jewel analysis is a really critical thing to do early on. And it's a heavy lift, but it'll really help you understand what could go catastrophically wrong and why. So we move on from architectural understanding to build passive and active defense for our OT environments. So let's move on a little bit in maturity. So now we have 5 recommendations from our last year-end review report at Dragos, and I agree with them all, so I'm just going to read them to you. So the first one is build defensible architecture. So we've kind of talked about that already. We want to make sure that we have things properly segmented, we understand our environment, et cetera, et cetera. So properly segment, properly control access from one part to another as best we can inside our industrial environment. We also want to start implementing network monitoring. So a lot of these environments have no monitoring in place already, but that's okay. We can start building some passive monitoring. That's not an intrusive thing. We can start building some monitoring off a span port or a tap, and understanding our asset inventory, understanding threat detection, things like that. Establish remote access authentication. These are a squishy center, okay? So we talked about the Purdue Model, and hopefully you've got some kind of DMZ between your internet-facing enterprise environment and your industrial environment. Hopefully you have some kind of DMZ between the two, and it's relatively secure. And this means having something like jump hosts and multi-factor authentication to get across that DMZ into the industrial environment. Because I mentioned these protocols are insecure, these devices are insecure. Once you get into the industrial environment segment, things are kind of squishy in the center. You have the hard candy outside and the squishy middle. You don't want people getting in there if you can prevent it. Vulnerability management. Again, you're going to need a separate vulnerability management program for your industrial devices because the needs are so much different. When you can shut things down, when they can actually be updated, and what that means for your security posture. And finally, creating an incident response plan for your OT environment. What are you going to do if something goes catastrophically wrong there? What do you do if you detect something malicious or there's a potential cyber attack? I'm an incident responder. I come into a lot of incidents where this plan hasn't been made, and what I do for the first day of incident response is figure all this stuff out because nobody's ever done it. It slows down incident response. In a crisis, it costs more. It's much more expensive to have me do that than you do it right now. So here's some basic questions your incident response plan in OT should answer. When's an OT incident declared? So what are your declaration thresholds? They should be related to those consequences we talked about. Who will do what, when? How do you involve both your cybersecurity people and your OT people? They both have to be part of this response effort. How will they contact one another? Have you established that in advance? Out-of-band communications, document sharing, resource sharing, etc. How are you going to do that? And how are you going to call one another in a call tree, etc., if something goes wrong? I see some people laughing at each other right there. Obviously, this has gone catastrophically wrong for you. I've seen it go catastrophically wrong a ton of different times. How do you even do OT forensics? We're talking about PLCs and things. What are you going to do if you have a potentially compromised PLC and you need to know if the firmware has been tampered with? Who are you going to call? Is it a CERT? Is it a vendor? Do you have somebody internally who can work with that? It's a different world of forensics. Do you have forensic stuff that can do forensics on Windows NT, if that exists in your OT environment? You need to work this stuff out in advance. Where's the big red button or X? How are you going to cut things off in an emergency? So how are you going to hit the big red button or chop off network segmentation if, say, ransomware is spreading through your ICS environment? That's a really tough question. And safety concerns and requirements. You're talking about hazardous environments. Do you need PPE? Do you need to be wearing a hard hat? Do you have that? Can you buy one quickly? There's a bunch of different concerns that go into OT incident response planning. Collection management. This is really, really important as well. You need to know what data you have available to do analysis and monitoring and incident response in your OT environment. How long is it retained? You might know this well for your enterprise environment, but again, we're talking about an entirely different environment with entirely different concerns. So you really need to, you don't necessarily have a Splunk index list that you can use. You need to build an Excel spreadsheet of what data sources are available in your ICS environment. And finally, let's talk about moving on into the future. Okay, so as you're talking about moving on to higher levels of maturity, an important thing that I can tell you is find out how mature you really are right now, not based on your own negative or positive biases. So you really need to rate your maturity in your industrial control network in terms of cybersecurity and understand where you stand compared to everyone else. That's going to tell you whether you should move to more advanced things like threat intel, etc. So a tool I will suggest to you that you can take home today and do something with is the US Department of Energy's C2M2 model. It's a self-survey that rates you in 3 levels of maturity, from 1, 2, and 3. Level 1 is just basic fundamental maturity, the things we've been talking about today. Moving into maturity level 3, where you're a little bit more advanced. And maturity level 3 is the most sophisticated modern cybersecurity programs with the correct staffing and everything complete. And what you're going to do is rate yourself across a number of categories in cybersecurity, and then you'll take a look at these graphs, and it'll show you whether you've completed all of maturity level 1. And you don't want to move to maturity level 2 until you've completed all the things at maturity level 1. This takes a couple days to do the whole thing. Sit in a room with your operators, your engineers, your network people, go through all the questions, be honest. This will help eliminate that bias about where you really stand and where you should go next. Because again, if you see that you're jumping ahead to the maturity level 3 stuff and you haven't done the maturity level 1 stuff, you need to start with the fundamentals in your ICS cybersecurity program. This is a really important tool. Now, if this is all too much for you, I understand. I've thrown a lot at you right now. We've gone through the entire world. This is normally a 5-day class at SANS, and I've dumped it all on you in 40 minutes. Start with the basics. Anything that you can do here matters. At least understand what you need to secure. Start with the fundamentals. Try doing a tabletop exercise that involves your processes and your industrial control devices. Be humble when you're relating to your operators and engineers. Those bad relationships are probably there, and you need to start from scratch. Bring your pastries, be humble, ask them questions, learn about your process. It's probably really interesting. And they want to help, they want to educate. Everybody wants to talk about their job, right? Projectize the longer term things. If it's really hard to start building out passive monitoring in your industrial network, take your time, build a project around it. Start with the fundamentals first. But anything that you can do today will save you time and money if you have to call in a person like me. I want to save you money. I'm a terrible salesperson. Yes, you should have a plan for incident response in your ICS environment. That's a must-have. But it's very, very important to have as much prepared in advance as you can, because you don't want to pay me at incident response rates to do that for you at the beginning of an incident. And leverage outside resources when needed. We're here, but all of our major competitors in the ICS cybersecurity landscape are also in the vendor hall right now. I am a terrible salesperson. I don't care who you find to help you do this. Find somebody to help you do this. It's very, very critical from a health and safety and cost-saving perspective to secure your industrial environments, whatever those might be. Go out and find help and begin to do this today. It's really, really important. Thank you, everybody, for having me. I'm so grateful to be here. Of course.
Lesley, that was wonderful. We're so excited to have you here. We're slightly over time. I want to ask a couple of quick questions. Naive idiot outsider to all of this, but I assume as we move into this genuine world of Internet of Things and hundreds of millions or billions of more devices all start getting connected, this area only grows in importance and complexity. Is that right? Are we just at the beginning of this sort of taking off?
The ICS world has been a harbinger for what's happened in smart devices and IoT. Everything that is new and horrible about smart and IoT has happened before in ICS. So the connecting everything to the internet and the devices without security built in and things becoming more and more commercial, all of that happened already in ICS. And yes, it's only continuing to get worse with IIoT and IoT. So this problem is not going away. It's only increasing. And you're going to see more and more of these digital devices that are connected to the internet, connected to Bluetooth, connected to one another, out there in your environments.
Fantastic. Lift this lid up because I want this in the photo and getting the guy to take it.
I'm
so going to print you a little prize there. Final question. If you talk to 100 organisations about this, you've got 100 organisations in the room. First question, how many of those 100 are anywhere near across this issue enough for your liking on average in business?
You know, we did a survey of how many people have incident response plans in general, and that number, for the whole company, both IT and OT, and that number was relatively low. It was certainly not 80%. And then when you look at people who have specifically OT incident response plans and some kind of security program around OT, it's even lower. So I had an opportunity today to reach out to all of you and try to convince a few more percent to start building this program. It's really important. I get called out for some really catastrophic things you'll never see in the news.
Okay, so busy people, lots of things. They know there's all these things they should get to.
Yeah.
If this is reaching out to them, what's the single idiot simple takeaway thing they can do right now to significantly bolster their strength in this area of all the things you talked about?
Go to the bakery, pick up a box of pastries, take it into your process environment, watch the safety concern signs so you don't go in there and look like an idiot, and meet your engineers and your operators and understand what they do. Start with that. Start with a conversation. Hi, my name is Lesley. It's very nice to meet you. Can you tell me a little bit about what you do? I brought you some donuts. You know, whatever works. Do that today.
Fantastic. And now you just have to smile for this camera because I want a photo with you. Give Lesley a massive round of applause. That was tremendous. Thank you.
I'm so glad you liked it.
You can see why we were so excited about having her here. What a fascinating conversation. We're not far away from morning tea. You may well be able to grab her and deep dive into the subject for a few minutes during that as well. Our final speaker for this morning is currently a senior sales engineer for Airlock Digital, which you know is an Australian company that provides solutions for organisations to implement Allowlisting. One of the essential ladies herself, professed Splunk fanboy, who isn't, formerly a computer security analyst and focused on all things blue team, especially DFIR and CM. When he's not on a computer, you'll probably find him organising sec talks in Adelaide, enjoying all that Adelaide restaurant scene has to offer pre-COVID. And he likes to attend something here that says Levay Music. Levay Music. live music. Get back, tough crowd, had to move on. Okay, here to bust out some rocking cyber busting beats on the topic of finishing your Essential 8 program, being successful with Allowlisting. This is DJ Josh Schwartz from Airlock Digital.
Excellent. Thank you, Adam. So hopefully my slides will come up soon. My name's Josh Schwartz. As mentioned, I'm a senior sales engineer with Airlock Digital. We'll come back to those guys at the end. I've got a history in a range of different technologies. I've done everything defensive security, but basically summarized, I love preventative security controls, and that's how I've ended up here at Airlock Digital. Huge fan of purple teaming, so come find me on the booth if you want to have a conversation. And yeah, as I said, self-professed Splunk fanboy. So, I don't want to sound like a broken record, but I really just want to make sure we're all on the same page here. So I'm going to be talking about the Essential 8 today. I'm sure everyone's heard it. You've heard it a million times. It's been, smashed into your brains. But just in case you haven't come across it, this is a list of 8 controls that the Australian Cybersecurity Centres put together. They put them together because they actually work. These guys are the ones out there doing incident response every day. And so these are the 8 controls that, if you've got them all in place, massively reduce the risk of cybersecurity attacks against your organisation. So hopefully you're doing a lot of these already. Some stuff's really simple. Patch your machines, turn on two-factor. Some of them have a reputation for being a little bit harder. I want to challenge that, and we'll get to that. But the reason we always bang on about it is because it actually works. So if you look in the top left-hand corner there, you'll see number 1 on the list is application control. So let's talk about app control. What actually is it, and what are we trying to achieve here? So application control is the act of explicitly stating what is and is not allowed to run on the endpoint and making sure we actually enforce that. So we define a list of what's trusted in our environment, and then we run that. And interestingly, it blocks by default. So unlike antivirus or EDR, which blocks known bad, application control only allows known good. So it massively reduces our attack surface in our organisation, and it can even cover attacks such as lol bins or living off the land binaries, and we can again lock those down and really control those in a way that solutions like EDR and antivirus can't do. So there's this perception that this is hard to implement. I've heard a range of reasons, speculation. There's always horror stories flowing around. They deployed it and it broke something, or users got mad. I've heard all sorts. So, cybersecurity team doesn't have capacity. Service desk is going to get swamped by tickets and we can't do it. I don't know what to trust. These are all really common conversations. But I want to challenge these today. We've rolled this out in thousands of customers, right? And there's people doing this every day. So it's definitely achievable. So the trick here is that we need to plan to be successful. So a lot of people fail because they just grab a tool off the shelf for one that they've already got, or they buy the add-on for a solution they already have, and they just start enforcing, and they just start trusting and making exemptions and making rules. And this often leads to a bad outcome and these horror stories that we've heard. So it's really important that we start with the why. We need to understand, what are we actually trying to achieve? And just saying we're trying to achieve Essential 8 maturity is not a good enough answer. We need to understand, are we trying to control executables? We just want to stop that phishing attack and the user double-clicking on a binary. Or are we trying to control drivers, DLLs, system files, PowerShell scripts on the endpoint? These are really important things to consider. Things like, are admin users excluded? Do we want to control just for the user, or do we want to actually restrict what the administrator is allowed to do on those same machines? So basically it boils down to, are we trying to do anti-malware protection, or are we trying to stop, the non-marketing team from running Adobe software? So to help us understand this why, or choose our why, the Essential 8 maturity model can be a really good approach and help us kind of target what our end state looks like. So hopefully everyone's familiar with the Essential 8 maturity levels, but basically it's broken down into 4 levels. So it's all about risk mitigation and intent. So we can sit there and do a risk analysis of your organisation. Are you guys actively being targeted by APTs? Then highly recommend you target level 3. Are you a small, medium business with not many employees, not much IT, not much IP? Then maybe level 1 is more than appropriate for you. So if we break these down, level 0 is obviously doing nothing. Level 1's, you're proactively blocking executables. So the intent of level 1 is, again, dealing with that drive-by type attack, the phishing attack, the user gets an email and double-clicks on the file. As we step up level 2, we're now expanding that to the scripts, the libraries, the installers, and onto level 3, where we're now including bypasses as well, those living off the land binaries. So this is where we get into the really complex, complicated, mature stuff. So now we've picked our maturity level, and we understand what we're trying to achieve here. How do we actually kind of start making this practical? You've probably heard this a million times, but it's really important with application control to build a cross-functional team. So one thing that a lot of people seem surprised by when I come and have this conversation with them is that the most mature organizations that are doing application control, the cybersecurity team doesn't actually run the platform. They write some policy and say, here's what we want to allow in our organization, but from that point on, they're hands off. So because of that reason, we need to make sure that when you're rolling this out, you've got a cross-functional team. It's got representation from server admins, desktop admins, developers, support team, and of course the cyber and risk team as well. Cool, so once we've got the team, we need to start thinking about our use cases. So we really need to understand how our users work. So as Lesley just mentioned, it's all about sitting down with your users and understanding kind of, what are they doing and how are they doing it. So if we talk about some of the traditionally more difficult or perceived difficult solutions, we've got our developers. So, these guys are generating code, running weird code, compiling, they're doing all sorts of interesting behaviors. So we need to sit down with them and ask them questions like, what tools are they using? What languages are they writing? Do they have a build server? Do they have a pipeline? So the intent here is that we sit down with them and understand how can we control them and give them a safe environment, but not interrupt their day-to-day workflow. So, can they sign their code? If they can sign their code, we can do trusted publisher and away you go. Can we give them a specified file path? Hey, you guys shove your development tools into C/developers and away you go. So we can definitely find that middle ground and keep everyone happy. Remote workers. So we've seen over the last 2-3 years now, it feels like a blur, but remote work's becoming more popular. So we really need to understand what's the intent of the control when a user goes home, off VPN, takes their device off site somewhere. We want to make sure that is this security control meant to be enforced when they go home? Is it not? What happens if it can't talk back to the server or group policy or whatever it is? So we need to consider that and make sure we understand and what we want to achieve there. Another really common one is the executives. So we know they're always interesting people and their demands are never come through with 5 days notice. So we need to make sure that we're in a position where the world's not going to explode if the executive, is 5 minutes away from a WebEx meeting and we've forgotten to trust that in our policy. So we need to make sure we've got them considered in our use case. Another big one is IT. So IT, unlike a lot of users, they're doing quite interesting things. We have to think about what a day in the life of IT looks like. Not so much what they're doing on their machines, that's pretty easy to define. But they're making remote connections. So our security control might say we don't want users using RDP, but now how do we make sure that IT is able to remotely access those machines to provide support? So when we have these conversations with our users, these help us define and understand the test cases, so that when it comes time to test tools, we can jump in there and know what we have to test to make sure we're not going to upset our users. Cool. So once we've thought about all this, it's time to get into the boring stuff, the documentation writing, asking yourself lots of why questions. So the best place to start is asking yourself about the roles and responsibilities. So there's a lot to this, so you need to really unpack it. So you need to be asking yourself questions like, who's going to be responsible for the policy? Who's going to do the day-to-day administration of the tool, the updates and the maintenance? Who do the tickets get logged to? What's support going to be responsible for? What's going to be a ticket to cybersecurity risk team? So as I mentioned before, it's often not the cybersecurity team that's going to be living this day to day. So make sure you've really got clear definitions of who's responsible for what. This is a huge one. So we really need to understand the workflow and the day-to-day of what and how we're going to trust. So what is going to be the source of truth? Do you have an acceptable use policy that says we're only allowed to run this sort of software in our environment? Does cybersecurity have a rule about, if it pops up as malicious in the AV, it's not allowed to run in the environment? So we really need to think about what is the actual definition of what we trust. And from that, how do you add and remove trust? Who's going to be able to say that this program is now trusted to run in our environment? And who's going to be responsible for saying removing trust? So what happens if there's a supply chain attack and you need to rip it out? Is that something that support's able to do because the user's going to complain when that stops working? So we need to make sure this is really locked down. Another important one to flag here is know what external resources you're going to consult and make sure this is documented before you get into the day-to-day operation. You don't want to be waiting and looking at files and then going, I'll just check VirusTotal. Just have VirusTotal say it's perfectly fine, but it doesn't match your policy. Make sure it's really codified. And if you're struggling to know where to start, I highly recommend just trust everything that's in your organization. Most people are walking around assuming their devices and their environments aren't compromised. So that's a really good place to start. You can always go broad, trust everything, and reduce trust over time. Cool, so exception policies is a huge one as well. I mentioned the executive users before, so we need to make sure we understand and pre-plan who's going to be eligible for exceptions and who's going to be able to, add the users to the exception group and handle them. Again, we see a lot of people that do this successfully will have their support team able to generate the exceptions, and then we'll have the audit get sent on to the cybersecurity and risk team. So that's a really good approach to take. Another interesting point here is what's an exemption policy versus what's an actual policy change? Where's the line in the sand of you get a pass to run this once versus this is going to be allowed for my whole organization? We need to make sure that's clearly defined kind of before we get into actually deploying the software. Another really, really critical piece is you need to have a mature software deployment, a software maintenance program before you even consider doing application control. We see in our experience that the people that do this successfully have a really, locked down standard. We deploy using Intune, and here's our SOE image. That makes the world a lot easier place to work in. So yeah, the more uniform it is, the easier it's going to be to roll out. And worth noting here, a lot of people seem to think that the Allowlisting or application control project is going to be difficult because I've got a huge organization. It's actually just going to be difficult depending on how many different applications and how many different use cases you have in your organization. So you can imagine if everyone in your organization has local admin and they've all got Spotify and Netflix on their machines, this is going to be a much harder conversation to have. In a similar vein, the software development process, so I talked about talking to your developers and understanding how they work, but actually also knowing, how their pipelines work. How does the new code get introduced? If you've got application developers and the app's getting pushed onto a web server, how does that process happen and how can we inject ourselves into that pipeline? We need to make sure we really understand this because this is going to be the sort of stuff that really trips us up early on. And annoyingly, or at least annoying for me, I'm sure there's some GRC people out there that love it, but make sure this is really documented well. Make sure it's all codified. There's not going to be any questions once we get into the rollout phase. We know who's going to be responsible for everything, what's going to be trusted, and so on. Cool, so now we know where to start. A real pro tip for once you actually get into the deployment phase is make sure you're doing your people change management. We've got to make sure we're working with our users and not against them, especially if you're going to come along and start telling them that they're not allowed to do something. So again, make sure you've got a plan to work with users to understand their workflows and their needs, and make sure they understand why you're putting this control in place. And along those lines, make sure you've got an off-ramp. If you're about to come in and say you're only allowed to use Edge, you're not allowed to use Google Chrome anymore, make sure they understand why, but also make sure their bookmarks and their favorites are copied across. And same goes if you're blocking something like a Dropbox, make sure that you've told them they've got time to copy the files out and shove them into OneDrive. You'd be surprised how often people end up forgetting this step, and then you're just fighting users the whole time, and users are trying to find workarounds because they've got to get their file or they need this program to do their job. So we can make that really easy by working with them as we go through. When we come to the tech, in our experience, there's 4 key technical requirements that any software product needs to be able to do application control properly to those kind of level 2, level 3 maturity controls. So we need centralized visibility. So this is really crucial to see what's going on in our organization. I just mentioned, it's easier if you've got a SOE, but even with a SOE, we all live in the real world. We know that that's not what the environment looks like. So if we build an application control policy based off our SOE, we then roll that out, we're going to be, again, in this situation where we've missed stuff. So we need to make sure we're not working off one machine, we're working off every machine, so make sure that's coming back. You need the context at the point you're making the decision. You're going to be fighting the process if you're always having to, grab the hash from there or chuck it into VirusTotal and take the results and put them over there. So, make sure that you've got it all in one place, whether that's the tool itself, whether that's pumped into a seam, make sure you've got your the dashboard that you live in. Really importantly, you need to be able to push update out rapidly and frequently. So you need to be able to get those changes out to users near instantaneously, or at least very quickly. Otherwise, again, they're going to have a bad time. If something gets updated, you've pushed new software out to your environment and missed something, we need to make sure we can fix those problems quickly. And along those same lines, we need to make sure we've got methods for temporary exemption. So again, you never know when an unexpected update's going to head out. You never know when an exec's going to need to jump on some weird, wacky, wonderful WebEx or something. So we need to make sure you've got that in there. So bring this all back together. We need to understand our why and our what as step 1. So again, decide on your state maturity model, understand what you're trying to achieve, work with your cross-functional team, and understand your users' workflows to define your technical requirements. We jump into step 2, then we can now evaluate our technology against those technical requirements and those use cases, understand the limitations, and keep our users' day-to-day in mind. So we need to find the right technology for our workflow, for our users and our environment. Step 3 is the plan some more, plan again, and develop your business process. So make sure that edge cases are documented, make sure we know how we're going to handle them, make sure we know how trust is defined, and understand the roles and responsibilities across the teams. And hopefully, at that point, you should be able to deploy successfully with a solution that's not going to disrupt our users, it's going to enforce the exact policy we want, and will massively reduce the risk to your environment. So again, don't forget, application control is there to help you reduce your attack surface in your environment. So feel free to start with a broad definition of trust and cut it down. 5% of machines with a good application control policy is still 5% of machines that aren't going to get ransomware. Cool. So I just want to say a huge thanks to EMT Distribution for giving me the slot to jump up on stage and talk to you. So EMT is a crayon company, and they're focused on delivering proven, effective, and innovative cybersecurity solutions. So they've got a booth out in the vendor hall, so please go check them out and have a chat to them. I just want to finish off by mentioning Airlock Digital, the company I work for. So we were founded by people that were struggling with this stuff all day, every day, in Canberra, in federal government, doing it in the big leagues. They found themselves constantly fighting, so they decided to develop a technology that has all these decisions kind of baked into the product. So if you're keen to have a look, have a play, come past our booth, and we can get you set up with application control kind of there and then if you want to have a play. Thank you.
Thank you very much, Josh. Wonderful presentation. You rightly thanked EMT. All the sponsors make this possible. We're about to break for morning tea. The best thing you can do for the sponsors is get down there, go around the booths, check in with your app, do the passport thing, go in the running for great prizes, chat with some of these people who've made the entire event possible. Josh, thank you so much, mate. Wonderful presentation. We go to morning tea now, then break it to our parallel streams. If you're tossing and telling me, oh, do I want to come to the speed debate? You want to come to the speed debate. If you haven't seen it, it is the famous way that we finish off AusCERT every year. 6 topics in an hour, best luminaries in the industry tearing strips off each other and having a bit of a laugh too. So after afternoon tea, we'll see you all back here for the speed debate. Until then, morning tea and your parallel sessions. Enjoy.